everyone. My name is Srijan Kumar and my roll number is 25. In this project, I developed an end-to-end data visualization pipeline by first creating my own scholarship dataset through web scraping from the Buddy4Study platform and then analyzing this dataset using Python-based visualization techniques. The goal of this project was to transform unstructured scholarship information into a structured dataset and generate meaningful insights regarding scholarship opportunities. The project follows five main stages. First, scholarship data is collected from the Buddy4Study website. Second, Python-based web scraping techniques are used to extract scholarship details. Third, the extracted information is stored in JSON format as a custom dataset. Fourth, the JSON dataset is converted into a Pandas data frame for pre-processing and cleaning. Finally, multiple visualizations are created to analyze patterns within the dataset. For dataset creation, I wrote a Python scraper using Selenium and BeautifulSoup. Selenium was used to handle dynamic web page loading and navigation across multiple pages, while BeautifulSoup was used to parse HTML content efficiently. Scholarship. The scraper collected various scholarship attributes, including scholarship title, link, award, eligibility summary, last updated date of the scholarship, image URL, the logo of the scholarship, deadline date, eligibility, benefits, documents, important dates, and selection criteria. The scraper begins. The scraper begins by configuring a Selenium WebDriver for browser automation. It then navigates through multiple scholarship listing pages. For example, see we have this scholarship card. So first it scrapes data from here, the award, eligibility summary, the link and the logo of the scholarship. Then it goes further inside and scrapes data from here too. For each scholarship card, basic information is extracted, and then the scraper visits individual scholarship pages to gather detailed information such as benefits, documents, and deadlines. Duplicate entries are avoided, and all records are continuously saved into a JSON file. The resulting dataset is stored in JSON format. Each scholarship entry contains fields such as title, award, eligibility summary, deadline date, benefits, and other detailed metadata. This structured format ensures that a dataset is machine readable and suitable for downstream data analysis tasks. After dataset creation, the JSON dataset was loaded into a Pandas data frame. During pre-processing, missing values were handled, data fields were standardized, award values were interpreted and categorized, scholarships were classified into domestic or international categories, education levels such as undergraduate, postgraduate, and PhD were extracted. So let's see one by one what we did for each of the visualization. First visualization is rather very simple. It just tells us the frequency of each word in the eligibility criteria of our scholarships. Our second visualization sorts the deadline date by months. So since we scraped the data in the month of April, most of the data was most of the scholarships had deadline in the month of May. We also extracted. We also made an array uh, here of each of the state, and we found the if any of the eligibility criteria had keywords of the following states. So we found that Orissa had the most scholarships, followed by Arunachal Pradesh and Haryana. This is the histogram plot for scholarship award distribution versus number of scholarship. Uh, so most of the, as we can see, most of scholarships lie between normal tuition fee waivers, which lies over here, to 100K worth of scholarships. In this visualization, we sort the scholarships on the basis of award amount. The scholarship with the highest award amount is Google PhD Fellow India Scholarship, which has approximately uh, 4 million, uh, 4, 40 lakhs worth of scholarship. Then uh, we sort scholarships on the basis of education level. What we did here is we generated some keywords like postgraduate, PG, master, PhD, doctoral, or postdoctoral. And whenever we saw any of these words, we increased the count of PG by one. For UG, we found the keywords undergraduate, UG, bachelor, graduation, and college. For school people, we chose the keywords school, class, matric, 12th, 10th, and 11th. So as we can clearly see, PG people had the most number of scholarships. For them, scholarship opportunities open the most, followed by UG people, and the least for school people. This is the box plot for award amount by education level. So as we can clearly see, PG people have the highest award amount, followed by UG people, and all the school people have the highest variance. Their max amount is the lowest. This is the histogram plot for each school, UG and PG. This is the pie chart depicting 56.2% of our data set includes domestic scholarships, and the rest, 43.8%, is comprised of international scholarships. Domestic versus international scholarships by education level. So, as we can clearly see, PG people get the most international offers, followed by UG people, and school people almost get no international offers. This is the risk to reward ratio. So, as we can clearly see, higher the award amount, higher the documents were required, and lower the amount award amount, lower number of documents were required. And most of the scholarships required only three documents. Total scholarships we scraped were 96. Uh, we had 28 scholarships. We'll move further on. So, average scholarship award for domestic was our domestic scholarships were much higher than international scholarships. Domestic scholarships had almost 2 lakhs worth of had an average of 2 lakh worth INR, whereas international awards were 2. This is the histogram plot and this is the box plot. So some of the key insights of my projects were undergraduate scholarships are highly frequent, deadline peaks occur seasonally. International scholarships often provide higher financial benefits. Scholarship opportunities vary significantly across target demographics. During development, several challenges were encountered. For example, when we had to scrape data from the website, we had to ins we had to ensure dynamic web page loading, which was not at all easy. I had to learn the whole Selenium process. The HTML structures were constantly changing day by day. Missing or incomplete scholarship details were also a big problem. So whenever we restarted the scraping program, duplicate entries were created and dates were standardized and award formats were regenerated. So first of all, the award looks like this. Efficient English communication. So award also had some issues. For example, here fully funded scholarship. So we can't find the exact scholarship amount here, and there were problems like these two. We solved this by say Mm, say we did not count those scholarships, but say if we have award fee deduction of 10,000 euros, so we removed this part of the award and we just kept 10,000. Overall, the technologies used in this project include Python, Selenium, BeautifulSoup, JSON, Pandas, Matplotlib, Seaborn, and Jupyter Notebook. In conclusion, this project successfully demonstrates how web scraping and data visualization can be combined to create a complete analytical pipeline. By transforming unstructured scholarship data into actionable insights, the project showcases practical applications of data science techniques in educational opportunity analysis. Thank you. My name is Srijan Kumar and my roll number is 25.